All right, let's look at the algebra, the math 13-14 part of the review. So question 1 says, plot the point -4, 3. This is the x value, and that's the y. So it's -4 and +3. Hey,
Guess what? I got through pretty much all of
that's the point.
5.
That's the point -4, 3. We're doing the review of the final. Question number 2. Graph the equation y equals 1/2x plus 5. One, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 3, 4. So this equations is in slope-intercept form, where the constant is your y-intercept. So you put a dot there. Then you follow the slope from that point, since that's, so go up 1/2. So up 1/2. Connect the dots and you're finished. It's also how you do it on this chart here. It's going to be a line. So we go to 5, which is there. Go up 1/2. And that's our line. Find the domain of the function. So when we say we're looking for the domain, what does that mean? Now you have,
I mean, the X.
yes, they have domain and range, x and y. So look at what x's can I use in this equation? Are there any restrictions? Can they be negative? Can I put negative numbers in there? Yeah. Can I put 0 in there? Yes. 18 minus 0. Can I put positive numbers in there? Yes. So the domain is negative, all real numbers. Because this is the absolute value. The graph of the absolute value is like this. So the domain is already all real numbers. And all this thing does is shift to the right 18 spaces. And it's still going to look like that. Let's graph this equation. X plus 3y equals 6. So what do we need in order to graph it? In order to graph any graph, you either put this into slope-intercept form, or you could do it by finding the intercepts, the x and y intercepts. So let's do it both ways. If we took this equation and solve for y. Subtract x. 3y equals negative x plus 6. Divide each term by 3. The equation will be y equals, there's a 1 there, so it's negative 1 over 3 x. 6 over 3 is 2. So you'd plot 2, go down 1 over 3. Start at positive 2. Since it's negative, go down 1 over 3. And there's the graph. Or we could find the the x and y intercepts. And we can plot those. To find the x-intercept, what do? Set y equals 0 and solve for x. So if y is 0, x equals 6. So we know we're going to have an intercept at 6. For the y-intercept, set x equals 0. Get rid of that. And solve for y. Y equals 2. We plot both of those, connect them, we're done. Both ways will work. Yes, we're doing the practice exam. And the good thing about doing the practice exam is if you do it online now, then whatever grade you get 20% of that is your bonus points for your final. So if you make a 90, that's 18 extra points. It helps a lot. Write the slope intercept. So I want the slope intercept equation for the line that passes through -2, 1 and 4, -17. So what does the slope intercept form look like? Y equals mx plus b. We have to define the slope and the y-intercept. So we have 2 points. Let's find the slope. Y2 minus y1, x2 minus x1. Since this is 0.1, this is the x value of 0.1 and the y value of 0.1. This is the second point, so that's the x value of the second point. So that's what they are. So y2 is -17 minus y1 is 1. X2 is 4 minus x1, which is -2. That becomes a plus. Negative, negative, they're both negative. 17 plus 1 is 18. 4 plus 2 is 6. 6 goes into 18 3 times, so the slope is -3. So that was step 1, finding your slope. Step 2, find the y-intercept, right? Find y-intercept b. Using the same equation, we have a point. We pick either one of the 2 points, so let's pick the smaller one, -2, 1. And the slope is -3. Plug them in. That's X and that's Y. Negative is positive. 3 times 2 is 6. Subtract 6 on both sides. 6 is bigger than 1. It's negative. 6 minus 1 is 5. So we have our slope is -3. The y-intercept is -5. Plug them back into here. -3x plus -5. Positive and negative makes it a negative. And this is the equation. Six. Solve this equation. 4 minus 1/9x equals 10/3. First things, there's fractions and an equal sign. Whenever you have fractions and equal sign, get rid of the fractions. Find the LCD. What's the LCD in this case? You're thinking it's a 3 or a 9. It's the LCD. What's the smallest number that they both fit into? 9 fits in 9. Does 3 fit in 9? Yeah. 3 times 3 is 9. So the LCD is 9. We multiply the LCD to each term. So 9 times 4 minus 9 times 1/9x, 9 times 10/3. So I multiply 9, the LCD in front of each term. Reduce. So 9 goes into 9 once. 3 goes into 9 3 times. Because everything is 1 times 1 is 1. Multiply to remove parentheses. 9 times 4 is 36. 3 times 10 is 30. And solve. Subtract 36 from both sides. Negative x equals 36 is bigger. 36 minus 30 is 6. Change the signs. X equals 6. Number 7. Determine the intervals on which the function is increasing, decreasing, or constant. Okay, here's the graph. -10, -6, 4, -2. In between 2 and 1. Okay. So where is it increasing? Since this is an arrow here, it goes all the way to negative infinity. And then go arrow here, so it goes all the way to positive infinity. So it's increasing. So if you put your pen there, where's the line going up? Yeah, from negative infinity all the way to here. So it's negative infinity to -8. It's also increasing from -3 to -2. So increasing here to here. Decreasing. It's going down between -8 and -6. It's level, it's constant from -6 all the way to -3. And then from -2 to infinity. There has to be a connection between each of these. From negative infinity to -8. Okay, from -8 to -6. From -6 to -3. From -3 to -2. -2 to infinity. There has to be a continuation. It has to be continuous. Right. Using the graph, determine any relative maximum minima of the function and the intervals where it's increasing, decreasing. Max, min, increasing, decreasing. Okay. The relative, we have a maxima here. So that's the highest, that's the max. But this is the value. The maximum, we have relative max of 4.741 at x equals -1.333. Really?
So,
You kick butt there. And we have a relative minimum. You want me to be here next week?
yeah.
Okay.
Yeah, so it's
All right. Have a great weekend. So now we have a relative minimum of 0 at x equals 4. So when they're saying maximum minimum, they're talking about the y values. What's the highest or lowest? and they occur at those X values. See, that's what I ask you here. The relative maximum values of this occurs at X equals. So it wants the Y values in there and the X values here. Ooh, piecewise defined functions. So we have X plus 6, or X is less than equal to 1. We have 3 minus X for any X greater than 1. So we have to find G of -6, G of 1, and G of 5. Yeah, the final exam is on computer online. So we have 3 equations that we have to fix. G of -6, G of 1, and G of 5. Whatever's inside the parentheses is the X. So if it says -6, so is -6 is X is -6. Is -6 less than 1? Or is it greater than 1? That's, yeah. So for this one, we have to use this equation. We have to use X plus 6. So it's -6 plus 6 equals 0. In this one, next one, X equals 1. Is it less than equal to 1, or is it greater than 1? Yeah, so we have to use this equation again. X plus 6. 1 plus 6 equals 7. And this one says X is 5. 5 is greater than 1, so we got to use this equation. So 3 minus. Since it's 3 minus 5, since 5 is bigger, it's a negative, so the answer is negative. Okay. Number 10. Let f of x equal x squared minus 15. And g of x equals 20 minus x. Find f minus g of 8. So remember what this means. This means f of 8 minus g of 8. So f of 8, anywhere C in x, put an 8. 8 squared is what? 64. 8 times 8. You said 16, didn't you?
No.
64 minus 15 is what?
No.
49. Yes. So that's what f of 8 equals. G of 8 equals 20 minus 8, which is
Well,
yeah. It was up there all along. So we just have to find f of 8 minus g of 8. It's 49 minus 12 equals
37.
very good. And that's your answer. It's better safe than sorry. Ooh, okay. Let f of x equal negative 4x minus 1 and g of x equal x squared minus 2. Find f of g. Oh, f of g at negative 3. Now there's a difference. This means it's a composite function, the little O in the middle, which means it's the outer one and the inner one and its unit. It means f of g of x. So we have to first find g of negative 3. Because we have to work inside out. So negative 3 squared minus 2. Negative 3 times negative 3 is positive 9. Minus 2 is 7. So since g of negative 3 is 7, that's the inside, that's the unit that we have to solve for f. So we go to f, anywhere C and x, we put a 7 in its place. Negative 4 times 7 minus 1. Positive times negative is negative. 4 times 7 is 28. They're both negative. 28 plus 1 is 29. Because they're both negative, you add them. All right, number 12. Determine visually whether the graph is symmetric with respect to the x, y, or origin. The graph they used. Okay, so in our equation here, symmetric. About the x-axis, in other words, if you folded it this way, would the pictures be the same? No. The y-axis, if you flipped it this way, would they be the same? No. and origin. If you flipped it both ways, would they be the same? No. First off, because it's not, this one goes out 2.5, this one barely goes out 1. So this is, it's neither, it's none of them. So no, no, no. Determine whether the function is even, odd, or neither. F of x equals 4x to the 7 minus 2x to the 3rd. During class, we talked about there's a shortcut for this. Even equations. If all exponents are even, or if you have a constant. In other words, like f of x equals 5x squared plus 3. That's an even function because that's even and you have a constant. So that's an even function. That's an even function. So it could be constant by itself, an exponent with all, if you have a bunch of them, they all have to be even, or they could be combined. Only even exponents and a constant, then it's even. Odd, only if all exponents are odd and no constants. And neither if it's everything else. Yeah. So, basically what that means, if it's even, it flips across the y-axis. If it's even. If it's odd, it flips across the origin. So in other words, x, y goes to negative x, negative y. Oh, I'm sorry. So our example here, we're going to finish the question. Question is this one odd, even, or neither? The exponents, 7 and 3, they're both odd, so the function's odd, and there's no constant term, so it's odd. Describe how the given function would be obtained from one of the basic graphs. So if I start off with g of x equals x plus 5 squared minus 2. So what would I have to do? First, what's the basic graph? From the library of functions, remember we had those 12 different graphs? So there's x. Remember, if we took all of the bottom numbers, if there are any exponents, leave them there. Get rid of all the numbers on the bottom. If you got rid of all the numbers on the bottom, what you would be left with is that. So that's the basic function. So your equation will look like this. What's the first thing that goes from, when it goes from here to here, the first thing we do is a horizontal shift. It shifts to the left 5 spaces. because whenever it's inside the parentheses, it's always the opposite.
Mhm.
And then it goes down 2 spaces. It goes down to here and just opens up that. There's the graph. So what this one says is you would go left 5 spaces, down 2 spaces. That's the transformation. See, it's going to ask you, the basic graph is x squared. You're going to shift it left 5 units and down 2 units. Solve. 5x squared plus 15 equals 0. How do we solve this? Remember, we have to get x by itself. We're solving for x. Subtract 15 from both sides. 5x squared equals negative 15. Divide by 5. We're going to get the x by itself. X squared equals negative, but 15 divided by 5 becomes 3. To get rid of the square root both sides. X equals plus or minus. But we can't have a negative inside a square root, so it's I. There. All right, using the graph, answer the questions. What are the x-intercepts? What are the zeros? Here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 6. 4, 5, 6. It's just a little bit there. So it's asking for the x-intercepts and the zeros. Yes, in essence, they both mean the same thing.
Yeah.
They both mean that location there. It's just they're written different. X-intercepts are locations, are dots. So it's -5, 0. And no, it should be +6. +6, 0. Those are the x-intercepts, their locations, physical locations. The zeros are the x values that makes the equation 0. Yeah, because a lot of people get those mixed up. They are the same thing, so I can put them the same way. Use the quadratic formula. 2x squared plus 6x equals -9. It said use the quadratic formula. Negative b square root of b squared minus 4ac over 2a. And we're using ax squared plus bx plus c equals 0. So it has to be equal to 0 first. And then the a, b, c's are simply what's in front of the x's and constant. We have to move the 9 over first. So here, a is 2, b is positive 6, and c is positive 9. Now we just plug them in there. Negative b is 6. Plus or minus 6 squared, 4 times a times c. Now over 2 times a. Yes. Do the inside of the radical. 6 times 6 is 36. Negative, positive, positive, negative. 4 times 2 is 8. 8 times 9 is 72. 2 times 2 is 4. Negative 6 plus or minus negative 36. 36 minus 72. Negative 6 plus or minus the negative inside there makes it an I. So that becomes square root of 36. Well, square root of 36 is 6. So it's 6i. The top and bottom both have a 2 in common, so I can factor out a 2. Two and the 4 cancel. So my final answer is negative 3 plus or minus 3i over 2. That's the way you have to solve it. Find the zeros of the function. F of x equals x squared plus 9x plus 20. We can try to factor it or use a quadratic formula. Let's first go ahead and try to factor it. What makes x squared? X times x. The second sign is a plus, which means they're both the same. They're both going to be the first sign. They're both pluses. What times what is 20? When you add them, you get 9. Five times 4 and 5 plus 4. There. Now we have to set the whole thing equals 0 because we're looking for the zeros. So we set both of those parentheses equal to 0. Those are your zeros. -4 and -5 are your zeros. State whether the function is linear or quadratic. F of x equals 2.6 x squared minus 3.6 x squared. So is it linear or quadratic? Yes, exactly. Well, it's quadratic if the x has a 2. Yeah, even though that one has a 2, doesn't make it quadratic. It has to be the x. If the x does not have a 2, then it's not quadratic. Linear equations do not have any exponents on the x's. So it's quadratic. With the function below, find the vertex, axis of symmetry, determine max min. We got one? Oh. Determine whether the function, whether there's a maximum, and find the values. And graph. So f of x equals 2x squared plus 6x plus 4. Okay, first off, we know since it's quadratic, it's either going to be like this or like this. Since that's positive, it's this one. It goes up. So therefore, our vertex is the minimum. So let's figure out A equals 2. B equals 6. C equals 4. The formula for the vertex is negative b over 2a. And then plug it in there. Negative 6 over 2 times 2. 2 goes into 6 3 times. So it's negative 3 over 2. So we found the x value so far. This x value is also the axis of symmetry. So at x equals negative 3 over 2, we have our axis of symmetry. All right, so now we have to figure out what the function is when x is negative 2/3. So we have a negative 3 over 2. 2 times negative 3 over 2 squared plus 6 times negative 3 over 2 plus 4. Negative 3 squared is 9. 2 squared is 4. Positive times negative is negative. The 2 and the 6 cancel. 2 and 3 times, so 3 times 3 is 9. Well, I'll get that in a second. Two and the 4 cancel, so we have 9 over 2 minus 9 plus 4. Nine over 2. Positive and negative makes, since 9 is bigger, it's negative. 9 minus 4 is 5. It's 5 over 1. We could do the butterfly. 9 times 1 is 9. 2 times 5 is 10. It's minus between there. 2 times 1 is 2. And the y value is negative 1/2. There's your vertex. The axis of symmetry is negative 3 over 2. Since it opens up, we have a min, and that's the value of the min. It happens at negative 3 over 2. And then we'd have to factor it out. We have to find in order to graph it, since we have the vertex, we need to have we have the vertex and we have the y-intercept. All we need are the x-intercepts. So we got to solve it. Okay, so we have A equals 2, B equals 6, C equals 4. Let's use the quadratic formula. Negative B plus or minus B squared 4AC over 2A. Negative B is 6. 6 squared. 4 times 2 times 4 over 2 times 2. So we have negative 6 plus or minus 6 squared is 36. 4 times 4 is 16 times 2 is 32. Negative 6 plus or minus 36 minus 32 is 4. Square root of 4 is 2. Negative 6 plus 2 over 4. Negative 6 minus 2 over 4. Negative 4 over 4 is negative 1. Negative 8 over 4 is negative 2. So these are my x-intercepts. Negative 1, negative 2. 2, 3, 4. The y-intercept is 4. The vertex is at negative 3 over 2, which is negative 1, 1/2. Down 1/2. Because it's symmetric right here, If I go 1, 2 to the right, 4 up, I go 1, 2, and then 4 up. Because it's got to be mirror image. Since I have this out here, I have to have that out there. And there's my graph. Ooh, that was a long one. (21) Graph the function f of x equals negative x minus 4 squared. Okay, let's look at the transformation. The original function, remember, get rid of all the numbers and everything, we'd have x squared. Inside is our horizontal shift. So what you do here is set that equal to 0. And you see that it shifts to the right 4 spaces. Now, this negative in front just makes it flip across the x-axis. Because now, instead of all my answers being positive, they're not going to be negative. And there's your graph. Solve 1 plus square root of x minus 5 equals 9. To solve radical equations, you have to isolate the radical. So we have to get rid of the 1 first. So we have square root of x minus 5 equals 8. Let me see something. Okay. Get rid of the square root. We have to square both sides. So we have x minus 5. 8 squared is 8 times 8 is 64. Add 5 to both sides. X equals 69. And 23. Absolute value of x minus 9 is equal to 13. Remember, if you have the number inside there, absolute value of it always becomes positive. So when you drop the absolute values, that means I could have had a positive and negative. So when I drop the absolute value, it puts a positive and negative in front of the answer. So I have to do x minus 9 equals 13. X minus 9 equals negative 13. Add 9. So x equals 22. And x equals -4. You have to, when you set them both equal to positive and -13, solve it. Solve the inequality and graph the solution. Absolute value of x is less than equal to 2. So if we look at a number line, if x is less than 2, less than or equal to, so it's a solid dot, that means it has to go here. Since it has to be less than +2, that means it has to be greater than -2. So when you drop the absolute value sign of a less than, it becomes that's what it becomes. Since it's equal to. So from -2 solid to +2 solid, that's your graph. Determine the leading term, the leading coefficient, and the degree of the polynomial, and classify it as constant, linear, quadratic, cubic, or quartic. -4 x squared plus 9x plus all right, so the leading term. What's the leading term? Yep. Leading term is x to the 4th. Yeah, because they just trick you this way. So you look for the leading coefficient. Coefficient is a number. What number is in front of it?
No.
Yes, it's whatever's in. Yeah, it's just one. What's the degree? It's just the highest exponent.
Oh, okay.
Right. It's just the biggest. And is it a constant function? No, it's got x's. Is it linear? Can't be because it has exponents. Is it quadratic? Yeah, but it's got those bigger ones. It's cubic. It's quartic. So it's quartic. If it's cubic, this is the highest exponent. If it's quadratic, that's the highest. Use the end behavior diagram to describe the end behavior of the given function. -pi x to the 6th plus x to the 5th minus x to the 4th minus x plus 2. End behavior. So there's two things we have to look at here. The degree and the sign of the leading coefficient. So what's the degree? Highest, biggest. And the sign of the leading coefficient is it positive or negative? It's negative. Which means since the degree is even, if it's even, then both ends point the same direction. If the coefficient is positive, they're up. If it's negative, it's down. If the leading coefficient of the degree is odd and the leading is positive, the left goes down, the right goes up. If it's negative, it just flips. It's a decreasing function. So we know by looking at this, we have a y-intercept at 2. Both ends point the same direction. They point down. So we know it's going to look like this. And what happens in the middle, we don't know, because this says we can have up to 6 x-intercepts. Use the leading term test to try to figure out which graph. So what do we know about this graph? What's it going to look like? The degree is odd. It's 5, which is odd. So the leading coefficient A is greater than 0. It's positive. So what does that mean about the graph? What's it going to look like? Since it's odd, what happens to the end behavior? They go opposite directions. And since it's positive, it looks something like this. If it's positive, it's increasing. If it's negative, it goes down at the end. Yeah, since it's odd, it has opposite directions. We also know that our y-intercept is at -6. So if we look at all their have in their pictures, we know it can't be the first one. It can't be this one. It's a decreasing function. Can't be that because they both point the same direction. Can't be this because they both point the same direction. Can't be this one because it points down. It has to be this one. And the y-intercept is -6 down here. So it has to be D. They're saying is up in this point, you don't need to do a bunch of work. Just look at it. You can see what the basic shape's going to be. Number 28. Use long division to find the quotient and the remainder. All right, so we have the polynomial p of x is x cubed 4x squared minus 35x plus 91, and my denominator is x plus 9. So it's x plus 9, since we're using long division, we have x cubed, 4x squared, minus 35x, plus 91. So what goes in this first spot? Look at the first terms. What times x gives me x cubed? There's one here. How many am I missing to get 3?
Oh, two.
Yeah, so I have x squared. So now once I figure out what goes up here, multiply them to both of them. So x squared times x is x cubed. Positives. X squared times 9 is 9x squared. Change their signs and add. So it's 9 is bigger than 4, it's negative. 9 minus 4 is 5x squared. Bring everything else down. Since there's a number down here in front of the x, positive times negative is negative. What times 1 gives you 5? 5. I have 1x. I need to have 2. How many am I missing? 1 more.
Oh, one more.
Yeah, it has to be lower than this one.
Okay.
Just a hint. So now we multiply. Negative times positive is negative. 5 times 1 is 5. X times x is x squared. Negative times positive is negative. 5 times 9 is 45. X. Change your signs and add. The first term always has to cancel. 45 is bigger, so 45 minus 35 is 10. And bring down the 91. What, so positive times positive is positive. 1 times what is 10? 10. And they both have 1 x's, I don't need anything else. 10 times 1 is 10, x. Positive, positive. 10 times 9 is 90. Change their signs and add. So this is, that's your Q of x, that's your quotient. This is your remainder. Oops. Yeah, up here, that's your quotient. And that's your remainder. So you see what the question's asking for is the P of x, that's this big long thing, equals what? Yes, it equals, so the P of x equals the denominator, which is x plus 9, times the quotient, plus the remainder. So it's x plus 9, x squared minus 5x plus 10. And the remainder is 1, but it has to be over the denominator. And there's your equation. That's your answer. So it's the remainder divided by the denominator. Use synthetic division. Yay, it's not faster. Synthetic division. 2x cubed minus 4x squared plus 2x minus 15 divided by x plus 1. It's asking for the quotient and the remainder. Remember the process? Was what this one looks like is like it looks like this. So whatever you have in the bottom, set it equal to 0. And this is the number you're going to use. So when we set up, it's -1. Only the coefficients. So we have to have the coefficient of x cubed, x squared, x, and the constant. 2, -4 to -15. Bring the first term down. Multiply and add. So -1 times 2 equals -2. Add. -6. -4 plus -2 is -6. Multiply. -1 times -6 is 6. Add straight down. 6 plus 2 is 8. Multiply. -1 times 8. -8. Add straight down. They're both negative. 15 plus 8, 23. That's your remainder. And your quotient is going to be here. This is your constant, your x and x squared. So it's going to be 2x squared minus 6x plus 8. That's your quotient. And your remainder is -23. Use synthetic division, find the value, then check your work. So f of x equals x to the 4th, x to the 3rd, minus 9x squared plus 39x minus 32. Find f of 3. Okay. There are 2 ways you can find it. Because if you just plug this number straight in there, that's what this says. If we do f of 3, which is 3 to the 4th minus 3/3, 9 times 3 squared plus 39 times 3 minus 32. 3 to the 4th, 9 times 81 minus 27. 3 squared is 9, 9 times 9 is 81. 117 minus 32. 81's cancel. 117 minus 59. That's going to be a remainder. Because if you just plug in the number, you'll get the remainder. Or since we're looking for f of 3, that'll be our denominator. X to the fourth, x third, x squared, x constant. 1, -1, -9, 39, 32. So multiply. 3 times 1 is 3. 3 minus 1 is 2. 3 times 2 is 6. -9 plus 6 is -3. 3 times -3 is -9. 39 minus 9 is 30. 3 times 30 is 90. 90 minus 32 is 58. Same thing. That's our remainder. So the same thing would have happened if we have our x plus 1. If we just took our -1, plugged it in here, we'd get -23 as an answer. $30. And we just did that. It is 40. Yes, we're almost done. Find the polynomial function of degree 3 with real coefficients that are given zeros of -1, 2, -4. All right, so if my zeros are -1, 2, and -4, my degree is 3, that means I'm gonna have 3 answers, my x-intercepts. So what this means is that my x-intercepts are those. Set them equal to 0. So x plus 1, x minus 2 equals 0, and x plus 4 equals 0. Those are my factors. So x plus 1, x minus 2, x plus 4. Multiply those two together first. X times x, x squared. Positive, negative is negative. X times 2 is 2x. Positive, positive. 1 times x. Positive, negative, 1 times 2. So we have x squared, -2 plus 1 is -1. So I just FOILed the first two. Now I got to do the same thing here. All three of these have to multiply those two. X squared times x is x cubed. Positive times positive. X squared times 4 is 4x squared. Negative times positive is negative. X times x is x squared. Negative times positive is negative. X times 4 is 4x. Negative positive is a negative. 2 times x is 2x. Negative positive is negative. 2 times 4 is 8. Combine like terms. +4 minus 1 is a +3 x squared. -4, -2 is a -6x. And this is my polynomial that it came from. And all it wants to know is what my leading coefficient of the x squared. We just put a 3 in there. Pretty easy. Determine the domain of the function. F of x equals x squared 8 minus x. So in this one, I just want the domain. How do we do it? In a fraction, what's the only thing you cannot have in a fraction? Nope. In a fraction, you can never have a 0 in the denominator. Or the bottom. So the only thing we need to do is take the bottom, set it equal to 0. X is equal to 8. That's the only thing we cannot have. So our domain is from -infinity to 8 to +infinity. The only thing we cannot have is 8. Because if you look at a number line, that's the only thing you can't have. That's my restriction. So my domain is anything else can work. Find the vertical asymptotes. H of x equals 2 minus x, x plus 1. Remember, vertical asymptotes. Are x's that make the function undefined. Basically, it's x's that make the bottom equal to 0. So 2 minus x equals 0. X equals 2. So my vertical asymptote is 2. G of x equals x cubed minus 3x squared plus x minus 2, x squared equals 19. Find the horizontal asymptotes. Okay, horizontal asymptotes had 3 conditions. Remember what they were? you only look at the leading terms on both top and bottom. Everything else doesn't matter. Yeah. If n is bigger than m, they scored?
Right.
What's the score now?
0, 1.
Yes, that's what America won by yesterday, so I agree with you. So if there's more x's on top than the bottom, then the horizontal asymptote does not exist. If the top is smaller than the bottom, then if the exponent on the bottom is bigger, then it's 0. So the x-axis. There's the horizontal asymptote are the y values. And then if they're equal, if the exponents are equal, then the horizontal asymptote is simply the coefficients a over b. Okay, since there's more on top than the bottom, so there's n is bigger than m. Okay, there is no horizontal asymptote, but if the top is bigger by 1, then we have an oblique asymptote. Since the top is bigger than the bottom by 1, it doesn't have a horizontal, but it has an oblique asymptote. To find the oblique asymptote, use long division. So we have our equation here. Our denominator is x squared plus 0x minus 19. And the top is x cubed minus 3x squared plus x minus 2. And what's always going to happen, an oblique asymptote will always, because the top is bigger than the bottom by 1, it's always going to be a linear equation. It's going to be an x. Because what times x squared gives me x cubed? X. So x times x squared is x cubed. X times 0 is 0x squared. X times negative 19 is negative 19x. Change signs and add. Negative 3 minus 0 is negative 3. 19 plus 1 is 20. And bring down the negative 2. And because it's linear, we only have to do one more step. What times x squared gives me negative 3x squared? So this is a 1. Since they're both x squareds, what times 1 gives me negative 3? This is as far as you have to go. That's your oblique asymptote. Determine the oblique asymptote of the following function. Find the oblique asymptote of this function. Again. Two zero. Sorry, we're missing it. So Mexico is advancing. Saudi Arabia is going to be upset. The game's over. Is it finished?
No, not yet.
Okay. So since we have a denominator of x plus or minus a number, we can use synthetic division. So to use synthetic division, set it equals 0. So x squared, coefficient, x and constant. So it's 1, 3, -2. -1 times 1 is -1. 3 minus 1 is 2. -1 times 2 is -2. Yeah, it doesn't matter what the remainder is. This is x, this is your constant, so it's x plus 2. That's your oblique asymptote. Find the indicated value of the logarithmic function. ln of e to the -3. ln is the same thing as log base e. And the property said whenever you have a log of a number raised to a power, that power goes in front. And another property, whenever the base and the number are the same, that equals 1. I'll show you why in a second. So -3 times 1 is -8. That's your answer. So we're going to see what this equals. We don't know what x is yet. So let's convert this from logarithmic to exponential. The base comes over here and pushes that away. The log disappears, so we have a. What's the exponent here? 1. Since the bases are the same, so that's why the log, if the base and the number are the same, it's 1. That's one of the properties. Oh, another property. A log base anything of 1 is 0. Think of it. Log base a of 1 is equal to x. Push the a up, so we have a to the power x equals 1. The only way that can be true is if that's 0. Anything to the 0 power is 1. Another property. Convert the logarithmic to a logarithmic equation. E to the 5 equals m. So here we can label our A, Y, and X and just plug them in there. A is the E, the base. The Y is the 5. And the equal sign is M. Now I just go over here and plug them in the right place. Log A. A is E. X is M. And Y is 5. But log base E is ln. That's the answer. Yeah, so if you have a log base E, that's ln. If you have a log base 10 of X, that's just a log X. If there's no base in there, it's automatically a 10. If it's ln, it's base E. We have log, looks like base T of 40 plus log base T of 48. It says write it as 1. The property of this one follows this. Log X times Y. If I have a log and I have numbers multiplied, I could split them up. Log X plus log Y. So when you're multiplying them, it's a plus between them. If you're dividing them, log X over Y, then you're subtracting them. So I have a plus between them, so I could combine them since they have the same base. Then I have 40 times 48. Log base T. $19.20. So that would be your answer. Okay. This one says solve using Gaussian. It says solve. That's all I read. Minus 4x minus 3y equals 7. Minus 12x minus 9y equals 1. This is line 1. This is line 2. This is what's called a system of equations. And we learned substitution, elimination, or matrices, the Kramer's rule. So I like using Kramer's rule. But you can use any one of you can use graphing, you can use substitution or elimination. So let's use Kramer's rule. So here we have -4, -3, -12, -9, 7, and 1. Our main determinant is the original matrix. It's supposed to be straight lines, but I first multiply the -4 times -9, then minus the -12 times -3. Negative negative is positive. 4 times 9 is 36. Negative, negative, negative. So the answer would be negative. 12 times 3 is 36. Okay, so now because D is 0, that tells us there's no solution. Because to find X, we have to find dx over D. To find Y, we have to have dy over D. But if D is 0, you can't divide by 0. Since there's no solution, that means the lines are parallel. And you could see it because if I took this first equation and multiplied everybody by 3, I'd get this one. 3 times 4 is 12. 3 times 3 is 9. So the x's and y's would disappear. All I have left. So 0 equals some numbers. It's parallel. So no solutions. Oh, another matrix. All right. Four -5. -4, 5. 4, -5. -4, -5 minus 4 times 5. Positive 20 minus positive 20. Uh-oh, we have another 0. I should have gone a little bit further on the other one. So let's find dx. Remember how we do dx? We just take the answers and put it in the x column. Leave the y's alone. (13 times -5 minus -13 times 5). -65. Negative is a positive. 65. So that means 0 over 0. Let's see what dy does. Let's squeeze in the dy here. We have a -4 over 4. 13, -13. -4, -13, minus 4 times 13. -52. Oh, no, it's positive. Negative is positive. Minus 52 is 0. So dy is 0. Okay, so this last one, they all are zeros. Let's look at dx of this one. 7, 1, -3, -9. So we have -63 minus a -3. -63 plus 3 is -60. So because this top one, it wasn't 0 over 0 or 0, 0, that's why these are parallel. D of x and d of y are both 0. So we have 0 over 0, which means they're the same line. So you have infinite solutions. Everything's a solution since everything's 0. And that does it for that. So that's the end of the semester. Any questions?